Hello everyone, welcome to AWS and Linux Foundation course. So today the agenda is to talk about OpenSSH application and the application configuration, right? So we will talk about how the OpenSSH application is working and the configuration. Then we will talk about YAM as a package manager as well, right? So what does it mean, right? So far we talked about the Linux basics in terms of familiarizing with the operating system, the folder, the directory structure, and the permission, right? And the process management in terms of understanding how a command script will be get executed by creating that as a process, right? And the different process states. I think as part of the process discussion, we have understood that the service as well, right? And how the service will be up and running, how to manage the services too, correct? So this is a continuation to the services topic only, but we will be doing from the application perspective, guys. So the whole idea here is, as of today, in order to perform all of our Linux operating system related topics implementation, right? I was taking the EC2 instance from the AWS management console, right? And once the EC2 instance is created, I was logging into the server using the PuTTY, right? So without knowing how the PuTTY is actually logging into the EC2, we were logging in and doing the Linux operating system related configurations. Today the agenda is to understand how the login is happening to your EC2 instances using your PuTTY as a tool, correct? So what I do, first let me go and create one EC2 instance. I think let me choose the region here. I will be going to AP South 1 region to create my EC2 instance. Then we will be understanding how the login process is working to logging into your EC2 instances, right? And that's the goal for today, right? So simply let me go ahead and create a EC2 instance. I'm just going with the default settings, guys. Amazon Linux AMI T2.micro as the instance type and the existing key pair. Let it be the default networking setting and launch a instance. Well, it is now started creating a EC2 instances for me. The instance is ready, and as we know that it will be assigned with a default public IP. Let me take that public IP, right? And then let me log in into the instance by using the PuTTY, right? So when I use the PuTTY and you supply the IP address over there and you click on open, then you will be getting the login prompt. That is where you need to supply the username. The password I'm not supplying because the key was attached to the PuTTY, right? If you remember. So that key is considered as an authentication mechanism, and the key based authentication is happening by default when you attach the key, and it is allowing you to logging in. The whole idea for today is an understanding how this key based authentication is happening and how it is able to log in and how you are getting the bash prompt symbol in your terminal. So can I use this statement at this time? Anything that is happening in your Linux system is definitely because of a process. Without a process is created, nothing will happen, right? Even it could be a login, it could be a command, it could be anything, right? Is a process, and sometimes it may be a process that is created and terminated immediately, or sometimes there is a process that is continuously running on the system as a service or as a daemon that is responsible in doing these kind of activities, correct? So so now if you are able to logging into the server, definitely there is a service that is continuously running on the system which is responsible in validating whether the supplied username and the supplied key that was attached to the putty is good or not. If those are correct, then the validation will be successful. Then your system is allowing you to logging in, correct? So that is where now we are trying to understand which service is responsible in doing all these validations at the time of your logging into the server. That is called as a SSH application, right? So let me go to the architectural how the SSH application is actually working, guys. Right? I would like to present this to understand how the login process is working exactly. Right? Let's say when you create a EC2 server in your respective AWS region, right? Obviously, right? The the end user who is actually trying to logging into the server, that end user is using the putty, will be providing the IP. The request is going through internet, then the request is hitting on your EC2 server wherever it is running, right? That is how you are actually doing the login process. In your EC2 server, SSHD is the service name that must be installed, configured, running. That SSHD service is responsible in validating the request and verifying the supplied username and the credentials. If all good, then the SSHD service will be approving the login request. Then you will be granted with a bash shell. That's how the process is happening, guys. I think in the last lecture we talked about the cron D service, right? Cron D is the service which is continuously running on the system. Cron D service is responsible in managing the job schedules, correct? Like that, SSHD is the other service which is running on the system continuously. This service is responsible in getting the request from the clients, whoever is logging in, and validating that and giving the confirmation back. Is mean that in any Linux system, there will be multiple services that will be installed, configured, running. Each service is responsible for a specific use case. Like the cron D is a service responsible for managing the job schedules. SSSD is a service which is responsible for validating the logins, correct? When the multiple services are in the Linux systems serving the different services, then the each service which is accessible by the clients is available on a specific port number, guys. What is port number? The port number is the unique number that is binded to that specific service. Especially when the Linux server is giving multiple services, correct? As of now, we are discussing about SSSD service, but it could be any other service based on the different use cases, right? That's the reason every service is actually binded on a specific port number. The port number is just a identification number to know that the particular request is for which kind of a services. Let's say the SSSD service is really working on listening on binded on port number 22, then the client, whoever is sending the request to the server asking for a login, the request should be sent to the port number 22, right? The request that is received on port number 22 is responsible by the SSSD service. That service will take it up, will validate it, and will be sending the response back. That is how it works. You may be asking, what is this port number 22 still, right? Ideally, the Linux can be configured with multiple services. Here in the table, you can see that SSHD is a service that is purpose is to provide a login and the secure file transfer related services that is available on number 22. HTTPD is the another service that you can download, install, configure. That service is responsible in giving you the web application. This service is listening on port number 80. Like that, there will be hundreds of services that you can download and install, right? Those will be for different purposes. Each service will be binded on a dedicated port number just for the unique purpose. Got me? So that's how it is. So apart from the technical, if you ask me still what is it mean by the port number, I would like to give you one banking application, banking services as an example. Let's say you walk into any one of the bank. The bank is having multiple cabins. Each cabin is having a number assigned, right? The cabin 1, cabin 2, cabin 3, right? Each cabin is maybe giving you the different kind of the services. One cabin number is giving the deposits, loan, maybe the help desk or whatever, right? When you walk in as a client, right, the server, when I say server, the bank is giving you multiple services, right? Offering you the different services binded on a different numbers, right? When you walk in as a client, it's your responsibility to choose the right disk number, and you go to that specific number and start giving you your request. Then only your request will be validated, correct? Because there is a server which is already ready to accept your request on the specific designated port numbers or disk numbers here, correct? The same way here as well, your server is configured with multiple services with a specified unique port number. You as a client, what kind of service that you would like to access, you have to send a request to that specific number, then the server will receive it and will be processing it. Let's say when you would like to access a or log into the server, if you send a request to the number 80, it will not work. You have to send the request to only 22. Then only the SSHD will be responsible in that and will be processing your request. That's how it works. Make sense? That's the reason if I come back to my putty one more time, right? At the time of you are logging into the server using the putty, right? You see that when you give the IP address over there, by default, right, it is chosen port number 22 here, and by default the connection type is SSH. Because the port number and the connection type is automatically picked up here, you are not worrying about these two things so far, right? You are actually clicking open and logging in. But ideally, so you are sending the request to the EC2 server IP on a specific port number using the SSH service method. Then only the SSHD service that is currently running on the server side is responsible to take on the data that is came to number 22 labeling and will be processed. If you try to logging into the server using a different port number as an example, it will not work because you are sending the request to 28 port number, whereas the service that is running on the server side is responsible in listening on 22, and you are not going to the right server. That will not work, right? So I'm keep saying that there is a service that is currently running on the server side which is responsible in listening on the port number 22, correct? As we know that the systemctl is the command to see the status of a service. You see, SSHD is the service that is currently active running. SSHD service definition is currently located in USR lib systemd because SSHD is the systemd controlled service. This service is up and running since last 2 months. That is the time when I have actually launched my EC2 instances, right? So now this service is responsible for doing this login related activities. Let's say for some reason systemctl stop SSHD. Now let me verify the status again. Now the SSHD service is currently not working, correct? So now do you think the login will work? You see, I'm just trying to logging into the server. I'm still sending the request to 22 using SSH method, but still when you click open, you are getting the response as connection refused. Why? You are sending the request to the server on 22 number, and the service which is responsible to take the request on 22 is not available, and you are getting the refused error here, guys. So I'm just proving that, right? If you wanted to utilize any services from the server, the service must be in the running state on the server side, and the service must be assigned with a specific port number. The client who is sending the request must give the number, right, to which number your request has to go. Then only the things will be working. So when you are stopping the services, ideally the SSH service will not take on any more request, right, once you stop the service. But the current session, whatever you currently logged in, right, this session will continue to be working. Just to make a note, when you stop the SSH, it will be impacted for the newly coming request only, but the already existing established sessions will continue to be working. So I don't need to worry about the current login. So again, you run a start SSHD. Now you see that the service is started. When the service is in running state, yes, definitely the SSHD will start receiving the request on the port number 22. Now you should be able to see the login as prompt because the service is currently running. Good. If I go back, this means that the SSHD is the service which is offering the login services, right? So can I call this SSH as the one more new terminology called application? Yes. What does it mean by the term called application? Application is also a service which is actually installed, configured on a Linux machine, which is serving certain services to the clients, right? This SSHD service can also call as a application. So now my terminology is little changes. I have installed a SSHD application in my EC2 server. This application is currently running, listening on port number 22, and which is serving the services to my clients, right? So from the server terminology perspective, the term is service. From a business perspective, I can call this as a application, not a problem. Good. Let me clear the screen. When I'm saying that the SSH is actually a application which is running state, then the every application will have a home directory. In the sense, how this SSH application should work. Usually any application will have some settings, right? You always try to compare this with your traditional home-based Windows systems, guys. When you install any application in your Windows system, so there will be a option for you to do some settings to your application, right? What is your skin color, how your application should work. If it is a media-based application, definitely there is a volume controls, video controls, options. Basically, there is a customization that can be done for any application. Same thing here. SSH is the application that is currently running here. The application specific settings will be available in a specific folder path that is called as a home directory of a application. In the home directory, right, if you look through, there are multiple files, but out of them sshd underscore config is the configuration file for your OpenSSH application. In this sshd underscore config file, the settings will be listed. If you open this configuration file, it has already some details. Whichever the line that start with a hash, that is the comment line, that means these lines will be ignored. Whichever the lines are not commented, those will be considered. So in this sshd underscore config file, you see all these are the settings, right? These are the default settings, right? And if you wanted to do any modifications, can do that. Let's say, let me talk about one specific setting for now. Password authentication is no. That means, hey SSH, when someone is trying to logging into this EC2 server, do not accept the password based authentication. Always the users must submit a key as an attachment to the request, then only you accept that authentications. Remember, As of today, even I'm logging into the server by attaching a key in my putty to logging into the user called EC2-user, right? I'm not giving the passwords because by default the EC2 instances are not allowing the password based authentications. That is the settings that you see in your SSHD underscore configuration file. If you want, yes, I can go and do these changes, right? If you do little scroll up, you see authorized keys file. What this setting is telling, right? This is telling that hey, when someone is trying to logging in from using the key based authentication, so where will you be identifying the corresponding key pair available just to cross check whether the key is good or not. Like that, there are many number of settings that are available. We really need not to worry in understanding all the settings that are currently in the SSHD underscore config file, but understanding that this is the settings file where the settings can be customizable and can be modified here is good enough for now, right? Let me come out. Maybe to show you exactly how this settings file is impacted, maybe I'll try to create a user. You see, I'm creating a one more user account and I'm setting a password for my user. Let's say this is my password, right? So how the PR user can logging into this EC2 server? So far I was giving you the su command to switch, right? But when the user is created, the user can logging in from PuTTY directly also. Let's say I will give this IP address saying that hey, the user called PR is already created. You can logging into this server using a PR user. But when the sorry, but when the PR user is trying to logging into the server by using that specific EC2 server IP address, let me increase the font for a better visibility, right? You see, I'm giving PR as the username. Immediately you are getting an error that hey, there is no supported authentication method. Why? As of now, the SSH service is working to accept only key-based authentication. If you submit a key, it will be accepted or else no, right? That's the behavior. If you wanted to change that behavior, all what you need to do is go to your SSHD underscore config file, go to password based authentication parameter and make it as yes. You see, I'm changing the settings of my application, how it has to work on. Remember, whenever you are doing the changes to the configuration file, immediately you need to restart the application in order to take those changes it into the effect. We can do a restart or sometimes you can even do a reload as well. So then the changes will be get affected. Now if you try to logging into the server using the password based authentication model, you see I'm giving PR as the username. This time it is expecting a password to be supplied. Why? I made a change to my service saying that hey, please consider password based authentication as well, right? Because of that, now it is asking for the password. You supply the password and you hit enter. You see the PR user is actually successfully logged into the server using his own credentials by supplying the password also. So far I was not logging in from PuTTY directly. The reason the SSH will not accept it by default. If it has to accept it, we should do the changes. You guys should know what is mean by the SSH, how to do the changes to the configuration file, correct? So now I made a change to my default settings. Now it is able to, you are able to logging in using the password as well. Now I don't need a key to logging in. If you have a password is good enough to logging in. That's how you can do some customization to your SSH as well, guys. Let me clear the screen. You may be wondering here that how this SSH service is available here because we have not installed this, correct? SSH application is the basic mandatory application that must be available in all the Linux systems. Why? SSH is responsible in allowing you to log in, right? If this application itself is not installed, not running, then you guys cannot log in into the server. Then what can you do with the server if you are not able to log in? Hence the reason when you launch a EC2 server, the AWS will ensure that the SSHD application is installed, configured, running automatically with a port number 22. That default settings is already done. That's the reason the moment when you launch a server, automatically the SSH application is available for you and it is started accepting the logins from your external party clients. Make sense? So if it is not installed, yes, obviously you need to install, but SSH is the such a basic application that is available in all the Linux systems because that's the first level of the thing that you need to do logging into the server, correct? But any other applications very specific to your business will not be available by default. All those things you need to install it, right? Whichever the application that you are looking for based on your requirement, you download, install, configure by your own. But SSH you don't need to because that is a default which is available in all the Linux machines because without SSH you cannot log in first of all, correct? That's the reason. Good. Now the SSH is the default basic application that must be running. If it is not running, you cannot log in. That's the reason the default the SSH application is set to enable. That means if the system gets rebooted, automatically the SSH will be get started for you. Because if it is not started automatically, then you guys cannot log in, right? That's the reason. But just to show you, yum, yum is the command to install any of the applications. Let's say yum install, I wanted to install OpenSSH application. OpenSSH is the application name that you wanted to install that will be installing the SSH services, all these things. Why it is OpenSSH? Because SSH is the open source application which you can install and use it for free. You don't need to pay any licensing cost for the SSH. That is the reason the name suggests that OpenSSH. The yum is the command to manage installations in your EC2 instances, right? And install and specify the application name that you want to. But you see here OpenSSH is already installed because that's a basic application that must be there in all the Linux systems and it's already there, so we don't need to install it and do this. By default it is available for you, but you are trying to understand how the SSH is working, how you guys are able to logging into these servers and all these minimum basics. Make sense? Now I'm keep saying that the SSH application when it is running, it is listening on port number 22. In a sense, any client, any user is sending the request to number 22 that will be handled by the SSH, correct? How do we ensure that? Netstat-tupln. I'm giving multiple flags here to get a fine-tuned answer. Netstat is the command to see the networking statistics. This command is useful to know that the port number 22. Don't be worried in understanding the whole output, guys. Just focus on certain things, right? Wherever I'm highlighting, the port number 22 is currently listening by SSHD service, and when it is a service, the service is just a process. We can see the process ID as well here, which process ID is now the SSHD is running on the port number. This is confirming that SSHD is currently working on port number 22. If anyone is sending the request on 22, that will be taken care of. You see, when you stop the SSHD service and you now try to look back your netstat command, The port number 22 is not even listing here. Why? SSHD is not listening on 22, and anyone who is sending the request on 22, that will not be taken care of. So this is the best command to verify the port status, right? Which service is listening on which port number, all these things. Let me start it again, right? That means when you are working on any application, first you need to download and install the application. In this case, I don't need to install because this is already installed by default. Second thing, you need to understand the home directory of the application, in which directory the application specific settings configuration is located. In this case, /etc/sshs is the home directory of my SSH application. The third thing is verify the configuration file, in which file you need to do the settings. Fourth thing is once you do the changes to the configuration file as per your requirement, the way how I have modified, hey, accept the password based authentication, right? I made a change. Anytime when you do the change, you have to reload your application so that it will start getting the changed configuration and it will be working accordingly. The fifth thing, so every application that is actually serving the services to the end users, I meant to say to the users, that will be on a port number. So we need to verify the port number using the netstat command just to ensure that your application is running fine without having any issues and the port number where it is currently. Good. So that's the story about the SSH application, how the SSH is working and how you guys are actually logging in from your PuTTY, and also enabling the password based authentication as well. If you don't want the key based authentication, how the settings can be changing there. Good. Let me go back, right? And the systemctl command, whichever the one I'm using here to manage the services, this is the privileged command, guys. This command will not work from your ordinary users. This will be run only from the root account only, just to give you the heads up about this particular command. Good. Let me clear the screen. I'm saying that yum is the command which will be helping us to install the applications, right? Of course, here I don't need to install the SSH because the SSH is by default installed for you, nothing to be done. But if you see, maybe there is one application which is not by default available. Yes, you go and install it. Same thing like if you are using the Windows system, by default, the Windows comes with some applications. Whichever is not found, you download and install it, right? Same thing. Let's say yum install. Okay, I wanted to install one specific application, right? The application name is tree. Again, the terminology is little important, guys. When it comes to the yum, right, the application name is called as a package name, right? Rather me using the terminology called application, so here I'm using the terminology called package. At end of the day, all are same. For which context we are using this, based on that we are keep on changing the terminology. Sometimes I'm calling it as a process, sometimes service, sometimes daemon, sometimes application. Now I'm calling it as a package, right? So the term will be keep changing based on for what context that we are using this, right? So let's say tree is one of the package that I wanted to install here, right? So yum install and specify the package that you wanted to. I'm just showing the way how you can install a packages in the Linux system. You see, when you run the yum install command, first it will verify whether this package is already installed or not. If not, then it will start installing. The good thing with the yum command is first it will try to download the package for you. You see, right? It is downloading the package for you. Tree is the package name. It is downloading for 64-bit compatible architecture. It is downloading the latest version by default. This is where you can see the package version or application version, and we can see the size of the package that it is trying to download from the internet. Ideally, in a Windows, you go to web, the internet and you download the application .exe, then you double click and install, right? But here you don't need to. The yum will automatically go to the internet and download the package for you, right? The latest one. Good. Now you see that yes, it is downloading, so total 47 KB size, and it is asking for your confirmation. If you say yes, then it will proceed further in downloading the package for you and installing the package. You see, first it is downloading the package, then it is actually installing the package. Good. Once the package is installed, then that package will start giving you the available commands, services, whatever is responsible or applicable to that specific package type. Let's say when the tree is installed, right, the tree command will be available to you. This tree command is not there sometime back. It is available the moment when you install the tree package. What is tree command? Basically, the tree command will be helpful to see the folder hierarchy. You see these guys? Ideally, if you do ls-l, you can see only one level of child, right? But if you do the tree, you see under the where, this is the folder, under the folder, what is the child folder? You can see the whole nested tree structure, the child structure, the child structure, just to see what are the subfolders are there in each folder. That is what is the advantage of the tree command. That command is not there by default. I wanted to use that. I just have installed it using the m command, guys. Make sense? Let me clear the screen. Like that, whichever the package that you wanted to install can install it using the m command. M install, let's say I wanted to show you one more command or one more package. M install telnet. It will go and install it for you. You see? Done. When the telnet package is installed, the telnet commands will be available. What is the purpose of the telnet? The telnet command will help you to know that whether the port is available or not. Let's say, uh, let's say I'll take this IP. Okay. I wanted to know that this particular IP is accessible on port number 22 or not. Usually, how do you verify that the port number 22 is accessible or not on this IP, guys? You have to use your putty to logging in all those things, right? Rather me logging in directly, I just wanted to validate this IP is accepting the port number 22 or not. You see now, the telnet is trying to do a testing whether this IP is accessible or not on this port number, and you see, right? It is able to connect it properly. So that's the confirmation for you that yes, this IP is accepting the port number 22, right? I can give that example. You see, I actually stopped a service. Now let me use the telnet command. You see, the telnet is trying to connect it to the port number 22 of this IP, and the connection is refused. So here I'm taking the IP of my same machine, but ideally this IP could be any other. Let's say we have total 100 EC2 instances. From one EC2 server, I wanted to know whether the other EC2 server is listening on port number 22 or not. You just give that IP address here and use the telnet command to verify. That's how the telnet command works for you guys. All these different packages can be installed, can use as and when needed using the yum command. Good. So as part of the yum, I'm also giving you the discussion about the few other important commands as well, like a tree command and the telnet command to check the port status of any target IP addresses. Good. When you use the M command to install a package, maybe this time I'll go with any other package name called HTTPD, right? So let me hit enter. You need to understand that sometimes when you are trying to install any one of the package may need another dependency, guys. You see the dependencies here? If the HTTPD has to be installed, then it may needed some more dependency packages here. The M is intelligent enough to understand the dependencies. Whatever the dependencies are required to make this happen, all those dependencies will automatically calculated, automatically downloaded and install it for you. You don't need to worry about identifying what other packages must be there to install this. Get me? Sometimes in Windows systems, so when you are trying to install a package, you get a error saying that, hey, first you need to install the corresponding prerequisite, then you come back and install this, correct? Same thing here, the M is automatically downloading the required dependencies for you. You don't need to worry. All those dependencies will be downloaded and install it for you once you approve this process. Good. When you are looking into the version here, ideally this version has a specific meaning, guys. The first number is talking about a major version. The next version is called as a minor version. After that, whatever you see, that is the compatible architecture of a operating system. Here you can see AIM, Z and 2. That means this package is compatible to be running on the Amazon Linux flavored operating system. That's how we need to understand by looking into the naming pattern of a package version, guys. Good. Ideally, we don't need to worry about all this. The M will automatically download the corresponding compatibles, but it's better to know the meaning of all this. Okay. Now, if you say no, then it will not be installing. It will simply come out from this. The question that I have here is how the M command know that the package has to be downloaded from where, correct? Ideally, you go to the internet and you download the package from wherever you wanted to, and then you double click and install the package in the Windows systems, right? Here let's say how the M know that the package has to be downloaded from where. Make sense? Again, the M is maintaining the configuration in the file called /etc/ you know etc/m.repos.d, guys. Slash etc/m.repos.d is the directory where the M is maintaining the repository configuration files. These repository configuration files are having .repo as the extension. These files are having the details about the internet links, in the sense from where it has to download the packages, how it has to download the packages. That kind of the information will be available in the repository configuration file that are by default located in the m.repos.d folder. Again, if you are using AWS EC2 instances, you don't need to worry about all this. All are default setup for you, but we need to understand how this is working, right? Because if this is not a EC2 server, the Linux server is maintaining by a on-premises, then obviously you need to set all these things manually by yourself, right? Correct. So here you can see the Amazon core repository and Amazon extras repository. What is the terminology called repository, guys? Repository in the sense the place where all these packages are kept in. Ideally, these Amazon guys are actually keeping all these packages in one single place in the internet, so that whichever the EC2 instance would need these packages can go there and can download the packages and installing it for you. So the place where they are maintaining all these packages is called as a repository. Amazon core is the repository name where they are maintaining some common packages that must be required for any of the operating systems. Amazon Extras is the another repository where Amazon is keeping all the open source common the frequently used popular applications, right? So it has both information here, guys. If you open any one of the file, you don't need to understand this file content completely, but it has the details about right, from where it has to download the packages and the properties of the packages, right, all these details. So when you run the m command, the m will come to this location, will read this file, it will understand that from where it has to download the packages using this mirror list, then it will be downloading them. That's the reason when you are trying to install a package, you see this repository. This will tell that this package is actually downloading it from which repository of Amazon provided core repository. Let's say some packages may not be available in the core repository, guys, because if the Amazon is maintaining them in their repository, then only it can download and install it for you, right? Let's say some packages are not available in the core repository, that then those are available in the extras repository. To use the extras repository, the command is amazon-linux-extras, then list. You see, there are 67 packages that are currently available as part of this extras repository, and all are listed here. Whichever the package that you need, you take that name and install it, guys. That's how it works. There are many. I'll show you one example. Maybe I'll just take any one name just to show you how to install a package from the extras repository. So this is a install. There is a typo, guys. Right? So now you see it is actually trying to download the Ansible package that I have mentioned there. Now you observe here, it is actually downloading the package from the Amazon Extras repository. That's how it works. And of course, we should be understanding which package is available as part of the core, which package is available as part of the extras. We need to remember that, and accordingly we need to use the specific repo in terms of installing them, guys. Good. As anyway we are discussing about this m concept, sometimes or a question for you guys, do you think a package that is not even responsible at a base operating system level, do you think that package will be maintaining by the Amazon in their core repository for you to download and install it? No, right? Ideally, this is the Amazon Linux operating system. Amazon is responsible to give you the packages that are needed at a operating system level, maybe a tree command, correct? But the packages that are nowhere related to the operating system, that are third party applications, the extra application specific use cases that you have, those will not be in your default core repository. So the packages that are not OS specific, the packages that are very open source, third party, not so trusted by the Amazon as a vendor, those packages are available in a repository called EPEL. If you search for the EPEL repository, guys, which is the extra packages for enterprise Linux, EPEL is the repository name that is maintaining by the Fedora guys, right? The Fedora is one of the Linux flavor that is maintaining by the Red Hat company, right? So the EPEL is maintaining the packages uh, that are open source that are not very specific to the operating system, right? That kind of the packages are available in the EPEL. So when you are trying to download and install a package, if it is available in the core repository, fine. If it is available in the extras repository, fine. If it is not available in either of these two, then you need to get that package from the EPEL repository. So this is something outside of the Amazon control, right? Because this repository is maintaining by the Red Hat as part of their Fedora project. So how do you use that, right? If you see Amazon Linux extras list, the Amazon and Linux extras repository is actually maintaining the EPEL package as well for you. You see here, that means EPEL is available as part of the Amazon Linux extras. The step number one, you install the EPEL, that will configure the EPEL repository. Then you start downloading and installing the packages from the EPEL. That is possible. I'll just take one example here, right? I'm just taking, let's say, a stress command. You see, don't worry about what is this mean by this package, what this package will do, guys. I taken this as an example just to show you how it is. Let's say I wanted to install a package with the name called stress here. Okay, this package is not available. What I do, I would like to download this from the EPEL. The step number one, Amazon Linux extras, install the EPEL. First I'm installing the EPEL repository from my Amazon Linux extras. When you install the EPEL, it actually creates the EPEL.repo files in your m.repos.d, having the details from where it has to download the packages when it comes to the EPEL. Then when you try to install the package, right? If that package is available from the EPEL, you see it is trying to download it from the EPEL repository. Now, sometime back it was throwing the error. Now it is downloading it from the EPEL repository. That is how we can manage the packages right in the Linux systems, right? So yum install is the command to install the package. Yum remove is the command to, let's say, yum remove is the command to uninstall a package. You see now the package is uninstalled. Let's say yum remove, let's say I wanted to uninstall a telnet package. You see, now once the package is uninstalled, your telnet command itself is not working because that is not even installed here, right? So yum history is the command which will give you the history of the different transactions. You see, you install a package, you remove the package, you remove another package. What exactly is being done using the m command? Everything is available as a history with the timestamp exactly, and whether you have installed or you uninstalled, that entire history is shown here. That will just help you to understand what was installed or uninstalled in your Linux server using the yum as a package manager. What does it mean, guys? That means by default, when you launch a EC2 instance, right? So the Linux operating system comes with a default certain set of packages and applications, like how you are getting OpenSSH, right? On top of that, if you need any additional feature, any additional applications, you can always install them and start using them. Like I have shown you the tree command, telnet command, right? You can always install them. As part of the installation, use the m command. The m will download them from the core repository or extras repository. Sometimes it may be EPEL repository as well if you have configured it. Good. The OpenSSH is the default. That's the reason this is already installed. But any other uh, applications specific to your custom business needs to be installed and configured by yourself, right? So in the next lecture, we are targeting on the web server applications. Remember that day one, in the initial lecture, we talked about that first we should be having the awareness about the infrastructure, then some knowledge about the operating system, then we need to go to the application layer to install the application and start using the application, right? Really the time to discuss about the application layer. So we will install the Apache web server application. We'll see how to run a website services from your EC2 using the web server software that I'm going to install in the next lecture. Good. Now back to the discussion. Now let me go back to my SSH again, guys. That means a server is actually serving certain services by using the service that is currently running, which is available on a specific port number, and my users are actually sending the request on that port number to get a services or accessible, correct? Can I use this statement at this time? Any service that is serving the services to my users will definitely be available on a specific port number. Second point, any user who wanted to use the services, then definitely the request has to be sent to that specific port number. Third point, the service must receive the request on the port number to give the response back. Next point, can I say that without a port number, do you think a service can serve the services to the users who are accessing it from outside? No. Any service that is intended for a client access must have a port number to be available, guys. Then only the users can send a request on that specific number. Good. Can I say this? Let's say there is a hacker who wanted to hack my EC2 server. What does it mean by hacker, guys? I'm just using the very high level terminology here just to understand. Let's say there is a unauthorized person. Usually the person is not intended, not authorized to logging into my server. Can he try to logging into my EC2 server by randomly trying some username and password? Possible? Possible, right? Because the IP that is currently using for my EC2 server is the public IP. That IP will be accessible for everyone in the public internet, right? Anyone can use the IP. Randomly, they can try the username and password. If the username and password is matching, somehow you get a login into the server. So now there is no much security of my EC2 server because the server is publicly accessible and everyone can try it out by supplying some randomly username and passwords by sending the request to the port number 22. How should I be increasing the security levels of my EC2 server, guys? So that I don't want everyone is just logging into my server or trying to logging into my server at least. I wanted to increase the security levels. Of course, one level of security is as of today, you are able to use the key attaching to your request from my putty. Whoever is attaching the right key, only that guy can logging into the server or else no. Or whoever is actually, sending the right username, right password can logging into the server, no one else. Yes, one level of security is fine. But I'm worrying about what is the case your password or key is compromised. In the sense, someone know your key, someone know your password, then they also can logging into your server, right? How do we do a one more layer of security for your EC2 server is the question. Can I say this statement? Anyone have to use my services, they have to come to port number 22 only, correct? When it comes to SSH, at least, yes, they are all coming to a port number 22 only. Can I restrict the port number 22 is my question. Get me? Let's say if I restrict that, hey, The port number 22 should be accessible for a specific user only, not for all the people in the public internet. If I do that kind of a restriction, then the only a specific customer, a specific user can send a request accessing the number 22 port, no one else. How do you do that? AWS is giving you a one more firewall kind of a security layer to restrict the user access, which is called as a security group. Security group is the AWS resource that is acting as a network firewall. This security group is validating the incoming request. That means when the user is sending the request to the server, first the request will come to security group. Security group will verify whether this request is valid or not. If let's say the user is sending the request to the port number 22, right? If the port number 22 is allowed by the security group based on the security group rules, then only your request will go to EC2 server. If the security group rules are not mentioned with the allow rule, then your request will be get rejected by the security group itself. That means you cannot reach my EC2 server also. That is how we can put a firewall rule for your EC2 server with the security group help here. Even when the SSH is responding back, even the response also going through the security group. If the security group is allowing the outgoing traffic, then right that response will be sending back to you. Can I use this statement? Security group is the firewall rule that you can configure in your EC2 servers, which has the inbound rule and outbound rule. Inbound rule is to filter the traffic that is coming into a server. Outbound rule is the rule that is filtering the traffic that is going out from the server to the outside world. If these rules are allowing the traffic, then only the incoming and outgoing traffic will be accepted, or else no. That way, we can increase the security levels of my EC2 server and can decide who exactly can accept or can log in into my EC2 instances. Good. If that is the case, how should I be using this security group at first place in my EC2 instances? Let's say I wanted to launch a EC2 server, right? At the time of me launching a EC2 server, right, you have to choose the AMI instance type, key pair. Let me use the existing key pair. In the networking settings, you see firewall, security group. Actually, by default, it is creating a security group and it is allowing the SSH traffic from anywhere. That is the reason why you are able to logging into your EC2 instances so far without you doing anything related to this security. Because by default, it is allowing the traffic from anywhere, right, to your SSH services. That you can control here, right? Let's say you are creating a security group, right? And of course, allowing the SSH is must, because or else how you guys will be logging into the server, right? I want to allow the SSH traffic, but not from anywhere, right? I wanted to allow from my IP only. If you use my IP, it automatically takes your laptop IP as the source. That way, your EC2 will be accepted the logins only from your machine, not from anywhere in the internet. That's how we are putting a security in place. Or else we can go with a custom and specify the IP address manually here, saying that whichever the client systems are having so and so IP address, only accept these IP ranges, not for everyone. Like that, we can add your custom as well. Ideally, when it comes to the working environment in the real time, right? So it should be a custom and specify the organization company specific IP address there so that the server will be accessible within your company level, not from outside of the company. That's how we can restrict that the server should be accessible within a company specific network, not from outside, guys. Good. So that's how the security group can be created with a rule stating that the SSH can be accessible from which specific source range. Maybe during the practice we can go with the anywhere, not a problem, but remember that we need to go with the custom and specify the custom IP within a company specific or organization specific when you are working this for a specific project to increase the security of your EC2 instances. If you go to create a security group, one security group will be created and having these rules, right? Let's say you have a security group already created. Then you can just go to select the existing security group and choose the security group from the drop down. Anything is fine. These are the security groups that are already created with some rules, and if you wanted to use any one of them, just select that existing security group and proceed further. Whichever the rules were added to this group, those will be applied here. It's up to you whether you create a new or you wanted to use the existing, not a problem. You just worry about the inbound rules only. You see here creating security group sometime back, right? That way it is actually creating a security group for you and adding the rule. Good. If you open your EC2 instance that is just created, now security tab, you should be able to see the security group that is currently attached to this instance, guys. You see this security groups? This is the security group that is created for you. If you click this security group name, then it will open the security group with all the details. You see, the inbound rule says that the SSH traffic is now allowed from anywhere. When the source is all zeros, that means anywhere. Outbound traffic, if you see, the traffic is allowed. All the traffic is now allowed for everyone. If you wanted to restrict, right, you go to the inbound, edit the inbound rule, and can specify the changes. You see, SHS port number 22 should be allowed for everyone. Add a one more rule. You specify, let's say I wanted to allow the HTTP traffic port number 80 from anywhere. Like that, you keep on adding the different services that the server is offering on different port number, and you decide that should be accessible from anywhere, guys. That's how the security levels can be increased. Usually, you need to worry about the inbound rule only because that has to be secured. Should I be worry about outbound? No. Outbound is all about from the server, the traffic is going out. I don't really worry about that, right? So let all the outbound traffic is allowed, not a problem. But you worry about the inbound and you restrict the inbound not to be accessible for all the people. So if you make this as my IP, let's say, then this SHS will be accessible only from this specific IP address, not from anyone. If you remove this rule itself, then your SHS is not even allowed in the list. You see, no rules for my inbound. Do you think your EC2 server will be accessible now? This is my server, right? If go back to my server and let me try to logging into the server, guys, just to see the impact of a security group. This is the IP address. go to your putty. Let me try to log in. It will not work. Why? The security group is actually rejecting your request because the allow rule is not in the security group accepting the port number 22 connections for your specific source. So go to the security group of the server, go to the security group, then you change the inbound rule. However, you are expecting the traffic should be allowed, then it should be. You see now, I'm adding a rule. I want to allow the SSH traffic 22 port number from anywhere. Save the rule. Now you go back to the same session which was not working some time back. You restart the session. Now you see that the connection is established because your security group is now accepting your connection. The request is going to the server and it is able to respond back. That is the impact of a security group, which is increasing the security of your EC2 instances, deciding which traffic should be allowed, which should not be, guys, based on the source IP filtering concept in your security group. Good. We can see the security group list in the left side navigation, guys. We can just go down and click on security groups. You see all these are the different security groups that you can create and manage here and attach them to the EC2 instances as and when you need it, and control the traffic and increase the security of your EC2 instances. Hope we are good on this. So that way I think we are done for today's lecture, right? So as a summary, we have discussed about complete details about OpenSSH application, how it is working, how you guys are logging into the server on port number 22, managing the services using systemctl, understanding the port listen status, the M package manager to install a packages and managing the packages, right? And the various best practices in managing the application configurations. Well, so that's the story for today, guys. That means our next goal is to start installing the Apache HTTPD application, and we'll see what is that application, how that application will helping us to run our business applications like websites in the next lecture. Thank you.